Zero pod autoscaler automatically scales Kubernetes pods from or to 0 based on CPU usage and idle time threshold. ZPA gathers pod metrics and evaluates to downscale the deployment to 0 if the CPU usage of a pod falls below a certain threshold and the idle time of the pod exceeds cooldown delay. To understand how ZPA works, firstly create an AWS EKS cluster with 3 worker nodes as displayed in the New Relic dashboard and cluster autoscaler pre-installed. We will also deploy a sample app to perform load test. Add filter with the deployment name to view the number of pods scheduled and nodes allocated for the app. Initially, we'll go with 1 pod. We will be running a sample Gatling simulation script to perform load test. Choose simulation number as 1 and skip the description to start basic load simulation. The simulation is configured to make 1200 requests within 20 minutes. ZPA determines the CPU utilization of the pod and gradually scales out the replicas to meet increasing demand. Refresh the page to see the autoscaler has bumped the replicas to 7. On the other hand, cluster autoscaler identifies the presence of pending pods and add nodes to the cluster to schedule the pods. On refresh, you can observe an increase in the number of nodes from 1 to 3. Now that the Gatling load test is complete and no requests are in flight, ZPA scale down simulation starts. ZPA scale down simulation determines the CPU usage of unused pods. If the metrics of the pod satisfies the scale down criteria, then the autoscaler will downscale the deployment to 0 pods. On the other hand, cluster autoscaler identifies the underutilized nodes and removes them from the cluster. Let's go back to the dashboard view. Refresh the page to view the nodes and pods count. It is evident that ZPA has successfully scaled down the deployments to 0 pods and cluster autoscaler removed unused nodes from the cluster. Now let's have a look at how ZPA works to scale up the pods from 0. In the background, we will send a request to the application, downscale to 0, and ZPA activator detects the request and initiates a scale-up of the corresponding deployment to a configurable minimum replica to serve the request upon retry. On the other hand, cluster autoscaler will add a node to the cluster to schedule the pending pod. Here, we try to send a request to the app and encountered an error. ZPA activator will detect the request and initiate scale-up activity. Refresh the page to view the number of pods scheduled and nodes allocated for the app. Upon retry, the request is served successfully. This way, ZPA serves as the right tool to run workloads on the Kubernetes cluster in a cost-effective way.